All right, lesson 10.4, combinations. So combinations are very similar to permutations, except the only difference is when you're selecting combinations, order does not matter at all. So if you're selecting groups in which the order does not matter, like you don't need to consider the order at all, then that would be a combination. So for example, if you have a group of 10 people and you need to select groups of 3 to represent the school at a club fundraiser, that group of 3 people, the order will not matter. You're just selecting groups of 3 from a larger group of 10. So how many different ways can you select 3 different students from a group of 10? The order is not relevant there, so you would do a combination. And the button in the calculator you look for when doing combinations is NCR. The C standing for combinations. The N and the R are the same as in permutations. The N is, so in our example, the N would be the 10 and the R would be the 3. So if you have 10 students and you want to know how many different groups of 3 students can you select out of 10 total students, you would use a combination there. All right? So example 1 right here is just listing out all the different ways you could pick 2 letters from A, B, C, and D. Now, with combinations, if you pick the AB and BA, they're technically the same group, so you wouldn't count BA. AC and CA are technically the same group, so you would cross them out. So with combinations, the order does not matter. AC and CA really mean just the same group. It's the same pair of 2 letters, AC. Now, if you were a permutation, AC and CA would be different because order would be relevant there. But in combinations, order is not relevant. Okay? You order a chicken meal at Boston Market. You can choose 2 side dishes from a display of 8. How many combinations of side dishes are possible? So if there's 8 total side dishes to choose from, and you're selecting 2 of them, you would just do 8 NCR2 in your calculator. Okay, and this will tell you how many different pairs of side dishes can you select from a display of 8. And the answer is 28. All right, it's very simple. You get a great report card, and your mother is buying you 3 pairs of sneakers from Foot Locker. There's 20 pairs of sneakers on display. How many different combinations of sneakers are possible? So again, you must always think, is order relevant or not? Order here is not relevant, because if you're just buying 3 pairs of sneakers, like, it doesn't matter what order you select the sneakers in. You're bringing 3 pairs of sneakers up to the register and you're paying for all of them. The order is not relevant there. So this is a combination. So you would do 20C3. That's the question here that you have to ask yourself. Is order relevant or not? And you'll usually see a little hint in the problem. It'll literally say the word orders if order is relevant. Or it'll say arrangements. Like, arrangements and orders mean order. But here it says combinations. So that's literally, you're going to do a combination. There's 20 students in period 4 algebra class. 12 students are assigned to jury duty. How many different jury duty combinations are possible? So when you're selecting a jury, you're just selecting 12 people. Okay, it doesn't matter what order the 12 people are selected in. So this would be a combination. So it's 20C12. 20 NCR12 is big number. 125,970 possible juries. There's 42 songs on your iPod. You need to choose 35 songs for a playlist. How many different playlists are possible? Now, it doesn't specify that the order of the songs. I know with a playlist, like you think about order with songs on a playlist, but it doesn't say that. It's not telling us that the songs on the playlist have to be arranged in a certain order. And again, it says the word combinations right here. So it's going to be 42C35. It doesn't tell us that the playlist must be ordered here. That's what the key words you're looking for. Order or arrangements. Another big number. 269,783,28. All right. And then these 4 questions here, tell whether it's going to be a combination or a permutation. Well, very simple. The way you consider it is by thinking about if order matters or not. 4 students from your class of 120 students will be selected to organize a fundraiser. How many groups of 4 students are possible? So you're just selecting groups of 4 students. Groups of 4 students. It doesn't allude to the fact that the order of the 4 students matters. So therefore, this is going to be a combination. Doesn't say anything about ordering the groups of 4 students. Number 17, 10 students are auditioning for 3 different roles in a play. And how many ways can the 3 roles be filled? Here, order does matter because you're filling different roles. You're not just selecting 3 people and putting them in a group to do the same role. For all of them to fulfill the same role. It's 3 different roles in a play. So it's like you need to, so selecting A, B, and C, 3 different people to fulfill role A, B, and C. Those 3 people could be allocated differently to the different roles. So the order is going to matter in which they're selected to fulfill the roles. So that's a permutation. Okay, it's kind of like the problem we did in the notes the other day about winning a gold, silver, or bronze medal. Like how many different ways can 3 runners get those 3 medals? Like that's order matters in that. Order is implied there. To complete an exam, you must answer 8 questions from a list of 10. How many ways can you complete the exam? So if you're completing an exam, you're just answering 8 questions out of a list of 10. It's basically just choose any 8 you want. That's a combination. Doesn't matter what order you get them done in. It just wants you to finish 8 of the problems out of the list of 10. In how many ways can 5 people sit in a car that holds 5 passengers? So how can you order the people in the car? How could you arrange their seats in the car? That's a permutation. Because sitting in the driver's seat and sitting in the passenger seat is technically, they're 2 different roles, essentially, is what they are. It's like the seats in the car are like representing roles that each person could represent. So that would be a permutation. All right. Here's your homework, number 126 all. And that's it, just one video.